Hello everyone, in this video I'll be explaining class 10 science chapter 4 carbon and its compound. Now in this chapter we'll be studying some interesting topics based on our carbon atom. We will be learning about carbon atom, the element which is of immense significance to us in both its elemental and combined form. Now when we look around us, the food that we eat, the clothes that we wear, the medicines, our book, pencil are all based on the carbon atom. In fact, even us, all living beings are based on carbon atom. Now the amount of carbon present in the earth's in nature here is in the earth's crust. In the earth's crust, carbon is found to be about 0.02%, which is in the form of minerals, that is here in the form of carbonates, hydrogen carbonates, and gold and petroleum, And when we look the amount of carbon present in the atmosphere, it is 0.03%, that is which gives us our carbon in the form of our carbon dioxide. Now here the amount of, in spite of the small amount of carbon available in nature, the carbon has a great significance to us, and it is very important even though it is present in very small amount. Therefore, in this chapter we will be studying about the properties of carbon, thus which makes carbon very important to us. Now first, moving on to the explanation, we will study the bonding nature of carbon atom. Now carbon is an element with atomic number 6. Therefore, when we check the electronic configuration of carbon atom, we will see here it is 2, 4, which can also be written as 1s2, 2s2, 2p2. Now there are 4 valence electrons in carbon atom. The valence electrons are present in the outermost shell. These are carbon atom, the nucleus. In the first shell it has 2 electrons, and in the second shell it has 1, 2, 3 and 4 electrons. The outermost shell has 4 electrons. Therefore, we have 4 valence electrons in carbon atom. Now, to study the bonding nature, let us first see here one example. Now, remember these elements, they lose or gain electrons. Elements lose or gain electrons to attain stability. Now, for example, our sodium atom. Sodium has an electronic configuration of 2, 8 and 1, and chlorine has an electronic configuration of 2, 8 and 7. Now sodium needs to lose this 1 electron so that it has a stable noble gas configuration of 2 and 8, and our chlorine atom needs 1 more electron to attain it to become stable. Therefore, here our sodium will lose the electron and chlorine will gain electron, which gives us an ionic bond by loss and gain of electrons. This is from a metal. Metal loses the electrons and the non-metal gain that electron to give us an ionic bond. Therefore, we see here that the reactivity of elements is based on their tendency to attain a completely filled outermost shell. The outermost shell should be completely filled so that the molecule or the atom is stable. Therefore, elements, they form ionic compounds. Here, for example, our NaCl, sodium chloride, it is an ionic compound here by losing or gaining electrons from the outermost shell. Now, in the case of our carbon atom, when we see here, carbon atom has 4 electrons in its outermost shell. It has 4 electrons in its outermost shell, and therefore it need to gain 4 more electrons, or it need to lose the 4 electrons to obtain noble gas configuration. Therefore, let us study both the cases when it loses the 4 electrons, and the second case is when it gains electrons. Now, if our carbon atom, let's study the first case. If our carbon atom were to gain 4 electrons. Now, if our carbon atom gain 4 electrons, that means here the electronic configuration of carbon is 4. Now, if they gain 4 more electrons, they become 2, 8. That means it has obtained noble gas configuration. Now, when that happens, we'll be getting a C4 minus, and an anion is formed here. Therefore, now here our carbon atom it would require a huge amount of energy, and it would be difficult for the nucleus. The nucleus, since it has only 6 protons here, only 6 protons. The nucleus has only 6 protons, and if it can 4 more electrons, it becomes here. If it can gain 4 electrons, the total number of electrons becomes 10. Therefore, it would be very difficult for the nucleus with only 6 protons to hold on to 10 electrons, that is, after gaining 4 extra electrons. Therefore, a very huge amount of energy would be required. Now, that is the first case. Now, when we move on to the second case, if it loses 4 electrons. Now, when it loses 4 electrons, that means it becomes only, the electronic configuration is 2, 4. If it loses its electron, that means there are only 2 electrons left. Now, when 2 electrons are left, 2 electrons left, but there are 6 protons. Now the molecule itself becomes very unstable. Now here also it would require a huge amount of energy to remove the 4 electrons, leaving behind only the carbon atom with 2 electrons with 6 protons in the nucleus, with having and it is holding on to only 2 electrons in the outermost shell. Therefore, our carbon atom, it neither loses electron or gains electron, but they overcome this problem by sharing its valence electron with other atoms of carbon or with atoms of other elements. Now, not just our carbon atom, but even other atoms also, they share the valence electrons to form bonds. Now, for example, the shared electrons, remember the shared electrons belong to the outermost shell of both the atoms, leading the atoms to both attain noble gas configuration. For example, one example here is hydrogen has atomic number 1. That means it has only 1 electron. Therefore, 2 hydrogen atoms, they share the 1 electron each to form a covalent bond, and therefore they share electron. Hydrogen, they share this electron, and then they form a covalent bond, giving us H2 molecule. H2 molecule is formed. In the same way, our carbon atom has 4 valence electrons. It can form another, if we have another carbon atom with 4 valence electrons, they share these electrons to form a covalent bond in this way, with the same with atoms of different carbon atoms or with atoms of different elements. For example, in the formation of methane molecule, that is our CH4 molecule, carbon bonds with 4 other atoms of hydrogen atom in this way. Carbon has 4 valence electrons, hydrogen 4 atom. Each hydrogen atom has 1 electron each. Therefore, hydrogen here, let me write hydrogen electron as a cross mark. Now they share this electron to form a covalent bond. Now we know that our carbon is tetravalent because it has 4 valence electrons. Now in order to achieve its noble gas configuration, carbon shares this 4 valence electron with the 4 hydrogen atoms. Now, therefore, such bonds which are formed by the sharing of an electron pair between the 2 atoms, this is known as a covalent bond. That means bonds which are formed by sharing of electron pair between two atoms. When two atoms share their electron pair, it results in the formation of a covalent bond, and such type of molecules they have low melting and low boiling points. Now we have one important property, we have very important significance of carbon atom, that its versatile nature. Now when we study the versatile nature of carbon atom, we will see that it has two properties. The formation of a covalent bond is by the sharing of electron pair between the two atoms. Therefore, there are two properties of carbon atom. The first one is catenation. Now catenation means what? Catenation means the ability of carbon atom to form bonds with other atoms of carbon atom, giving rise to large molecules. This property is known as catenation. Now compounds of carbon, they are long chain, they can be long chain, branch, or even arranged in rings. Therefore they can be single, double, or triple bond. For example, we have here CH3, CH2, CH2, CH3 in this way, or it can be branch CH3, CH, CH3, CH3 in this way, or it can be in the form of a ring also. Now when it is a single bond, when carbon forms single bond, they are known as saturated compounds. We will saturated compounds, and when if it forms double or triple bond, it is known as unsaturated compounds. I will be explaining the saturated and unsaturated compounds in the later videos. Therefore, compounds, they can have the single bond, double, or triple bond between their carbon atoms. No other elements have the property of catenation to the extent as seen in our carbon atom. The property of catenation is a unique property of carbon atom, where it can form large number of molecules, and hence the carbon to carbon bond is a very strong bond and is very stable. The second one is its tetravalency. Now tetravalency means we know that there are 4 valence electrons in carbon atom, 4 valence electrons in carbon atom. Now it is capable of bonding with 4 atoms of carbon, or with atoms of different element. We have seen here carbon, here hydrogen. It has formed 4 covalent bonds with 4 hydrogen atoms, or it can form bonds with 4 atoms of carbon atom. Therefore, the compounds of carbon, they can be formed with oxygen also, with oxygen, hydrogen. They can even form bond with nitrogen and many more, etc. Therefore, compounds, they give rise to specific, each of these elements, they have specific properties which depend on the elements other than them. That means our oxygen, hydrogen, nitrogen, etc. The specific properties depend on the elements other than carbon atom present in the molecule. Now remember, the bonds that carbon forms with other elements are also very strong, making the compounds form very stable. Therefore, this enables the nucleus to hold onto the shared pair of electrons strongly when carbon shares its 4 valence electron to form a covalent bond instead of losing or gaining electrons. And therefore, this is the versatile nature of our carbon atom. In the next video, I'll be explaining the saturated and unsaturated compounds. Thank you.